Hey guys, I should be scared because the guy before me had 75 slides and I only have 20, right? But I don't like to put too much content on the slides. I like to speak. So anyways, my name is Adwait Joshi. I'm the chief seer at Data Seers. And as the name suggests, we are a data platform currently focused on the financial services space. And our goal is simple. We give you the ability to see through your data as fast as we can. If you give us data real time, we'll give you real time data back. Right? Somebody earlier said, Hadoop is batch, right? So I'll tell you everything that is not Hadoop and not batch. But before we do that, I want to tell you a story, right? And the story relates to what we are doing. So how many of you have heard the story of Mahabharata, right? It was a war that happened 10,000 years ago. It was a war between the good and the evil. That's pretty much the war that we are fighting today, the war between the good and the evil, the good and the bad actors, right? And this war was extremely important from what happened for the rest of the world, just like how we are today, what happens in the fintech space, what is going to happen in the financial services space, how are we going to fight fraud? It's very relevant. And it was a war of technology, right? So let's just look at some metrics. Two families fought, right? One family had 5 brothers, one family had 100 brothers, right? They had some of the best warriors on one side, some of the best technology. They had army of demons. They had hundreds of thousands of people fighting on their side. The other side, it was 5 brothers. It was Krishna, who is one of our gods, and he did not fight. So he was only a strategist. He did not fight. And they had a very small army, right? What was the result? Who won? The 5 brothers won. And if you look at it, why did this happen, right? The other side had better technology, more people, more horsepower, whatever you want to talk about, right? The reason why that happened is because there was a very important aspect of this. The team was close and correct, the technology was right, and the timing was impeccable. Most importantly, there was strategy involved, right? And that's very important when you are working or fighting fraud in the financial services space especially, right? You have to have the right team. The team needs to know exactly what to do, when to do, what is happening. You have to have the right technology. You want to make sure whatever technology you use is going to give you the results, because guess what? If you think you have the best technology, you're wrong. They have the best technology. You guys don't, right? And the timing. If you catch fraud a month later, 2 months later, a year later, why does it matter? The money is already gone, right? So you have to be right on time. You have to, in a way, hit the iron when it's hot, right? And at the end of the day, it all goes down to your strategy. What is your strategy to fight fraud? So you have been hearing machine learning, AI, blockchain, big data everywhere. I take a whole different approach. Let's take a step back. Let's get some domain expertise first. I mean, there is so many data scientists who are willing to jump into the fire and try to write code and everything. But wait, do you even know the domain better? Like, do you know the domain? Do you know your data? Do you know what you're dealing with before you start writing code? And that is very important. So let's fast forward today. I kind of gave you guys the background that we are living in the world of fraud. How many of you guys in the last 12 months, and think before you answer this question, in the last 12 months, how many of your credit cards were defrauded? So they were used by other people, right? A few of them. How many of you had your identities stolen? Right? How many of you had money swiped from your wallet? Right? So what's the pattern here? Fraud has evolved. So nobody is going to pick your pocket anymore. Identity theft, pretty much we have LifeLock, this, that all of our information is on public. I can pull up anybody's name and social security number in a very quick way, right? That's the problem has evolved from that now. I'm actually surprised that there is so many people here who had their credit card stolen. In the last 10 years, my data was compromised once, very recently. And that too, they had a very interesting hack. They actually somehow got to my assistant's computer, who had my card number saved on her computer, and they got it from there and used it somewhere, right? But immediately I'm sitting here traveling, I get a text message saying that somebody used my card to buy a $3,500 purse online. I called Amex, problem solved. Fraud has evolved from that, right? So we live in a whole different world today. And what is happening is we are literally trying to catch up to these guys, right? And they're challenging up to us. They're saying, well, catch me if you can, because you can't. And it is relevant, very relevant, from a simple fact. So if you're a fraud-based company, right, for fraud-focused company, tens of billions of dollars have been funded. Banks have been fined over $500 billion. And this is public information. Go look up your favorite bank, followed by the word fine. Just Google it, and you will see it. It's not a domestic problem. It's actually an international issue, right? Money stolen, impossible to track. So you have to ask yourself this question. We have the technology. We have all this money in the world that people are willing to give us. Why can't we fight fraud? Why are we still so much behind? And to understand that, you have to understand a very simple problem. The problem of data complexity. We have volume of data, we have velocity, and we have the variety. And some of you might know this as a V3 conundrum, right? We can handle volume, right? How many of you guys work with terabytes of data today? Right? How many guys work with petabytes of data today? There you go. See, there is few people here. So it's become a joke, right? I don't care. I mean, just bring it on. I have servers, I have storage, blah, blah, blah. How many guys deal with velocity data today? Talking about transactions per second, right? There's a few here. And then how many guys deal with unstructured data, right? So now, put it all together. I'm going to give you large volumes of data. It's going to come to you very fast, and it's all going to be unstructured. What are you going to do, right? I call that as a toxic mix. It literally is a toxic mix, and you cannot analyze that. So let's take payments as an example, which is the area we focus on. If you look at payments, and how many of you guys are familiar with the prepaid industry? You guys know prepaid industry, right? Square Cash, Venmo, Zelle, DoorDash, MoviePass, Instacart, they're all prepaid. Every product has a different rule. It has a different velocity, right? I mean, I was surprised to hear when I saw some of these metrics that kids are going to Subway, buy a 6-inch sub, split it half, and transfer money, $1.73 to the other kid, right? And I'm like, we almost never see that. You know, we go out and we spend a couple $100, and I tell them that, hey, you know what, I'll get it this time, you get it next time, right? Those micropayments are creating a huge problem to keep up. There's billions of dollars moved in a very short amount of time. And what happens is that leads to a whole different type of fraud, which leads to money laundering, right? So on prepaid, nobody wants to steal your card because you're loading the money before you use it. So what's the point if I steal your card? There is no money on it. I can't use it. I'm not stealing your money. I'm actually taking your identity on a different side to do money laundering. And you would ask, well, I have my credit locked, and nobody's going to get cards on my name without me knowing. The issue is, any of these prepaid cards do not check credit history. They do not hit your credit reports. They only look for name, SSN, date of birth, which thanks to Equifax and Expedia and Orbitz, it's all out there, right? So it's very easy for me to get that information, get a card in somebody else's name in my hand, and now I am starting to either money launder or do trafficking. So what happens? What do you do then, right? Like somebody said earlier, Hadoop is batch. You know, you have this in real time, you have that batch, and all of the data has to move, and you have to analyze all of this information in near real time, because once the fraud is committed, money is gone. One technology comes to our rescue, and it is HPCC systems. How many of you guys know about HPCC systems? Right? Very few people. So let me give you a little bit of history. HPCC systems was developed in 1999, predates Hadoop, right? And it was a best kept secret. I actually have a blog post on this. It was a best kept secret because it was invented for a simple reason. I'll tell you the problem. Equifax wanted to predict who would bankrupt in the next 30 days so that they could go and do the collections on them. And that problem took 26 days to solve. Right? So the problem came, results came in 26 days. Now you had 4 days to act on and get the money back. Well, somebody had to solve it. So LexisNexis invented a technology called HPCC systems. This system was able to solve the problem in 6 minutes. And it made it so popular that they continued, that became a secret within the company, and they kept on going with it and making changes and making it better and so on and so forth. In 2011, there was a movement inside the company that said, this has to be open source. This is too powerful, we cannot contain it, and we have to make it open source. And they did. So in 2011, this technology was made open source. And it's truly free. So trust me, when you go to their website, download HPC systems, they don't ask you for your email. They already know who you are. You know, they don't want your money. They have billions of dollars, so they don't care. You can download it and use it. They'll actually even give you the courses for free. You can learn this technology for free, right? So it is open source, it is easy to use, and it is easy to maintain. And I'll walk you through some of the elements and then actually tell you one of our use cases. So if you look at the most important things of any data project, right? You have to extract, which is ETL, ELT, whatever you like to call it. We have to profile the data. You have to know what the quality of your data is. Then you have to clean it. Then you have to some way, shape, or form try to at least normalize it, and then run analytics on it. And whichever technology set you guys use today, there is very few pieces of technology out there that allow you to do all of this within one stack, right? Of course, Microsoft has their SSIS, but I mean, it's SSIS. It's not going to let you handle real-time data. So when you start talking about structured, unstructured, real-time, batch, all of that needed to be handled on a single system. I think HPCC systems is a extremely powerful engine, and it allows you to do everything in the box. So let's look at the architecture first. It's very simple. There is two major components within HPCC. Thor, as the name suggests, the job is to hammer the data in shape. And ROXY, which used to stand for Rapid Online XML Index Engine. Now it just says ROXY. So the thing is, it's basically two engines depending upon what you want to do. One is data massaging, and one is data delivery. Here is the fun part about HPCC systems. That's how it was intended. But this is open source, right? Anybody can use it any which way. We actually use it the reverse. We use the ROXY cluster to ingest messages. So it's not a data delivery. It's actually a data collection for us. And Thor is a data refinery. It actually still becomes a data refinery, but it's taking data in real time and batch at the same time. So that's the flexibility of the system. You can bring in structured, unstructured, semi-structured data, right? Think about LexisNexis use case. Banking information, public information, court records, driving information. I mean, they have 30,000 data points that they collect on you. They know more about us than we know about us. And it's not a joke. They like literally know 7 degrees of separation on a human being. Is like, who are they related to? So you guys may have a distant cousin somewhere that you don't know of, but they do, right? And it's all powered by this. Most importantly, they also have all of your machine learning libraries built into HPCC, right? So machine learning sits there, predictive modeling, data management, Thor, ROXY, all of that within one single system. It's all driven by a language called ECL, and it's Enterprise Control Language. And it's funny, I have been using HPCC for about 18 months in our company. I did not even know it existed before, right? And I don't work for HPCC or I don't work for LexisNexis. I mean, I have my own company. We are just using this underneath the hood. One of the things was very frustrating when we started, right? We think in terms of SQL. SQL's everywhere, right? So you start thinking in terms of SQL. ECL is different. It's actually very different. So if you look at it, it's a data-centric language. It's a declarative language. The language is very forgiving, right? And it's very readable. So what I mean by that? Data-centric means you have to think in terms of chunks of data. So don't think as a record set. Think about I'm manipulating tens of thousands of records at the same time. So your thinking has to change. So in In SQL, if you're writing a cursor, you're going row by row by row by row. That's not how big data technologies work, right? I mean, you have to deal with, I have 1.5 billion records in one of my smallest system. If I go row by row by row, I may never finish. So you have to deal with them in chunks. It's declarative, which means you can read it the way you write it, right? So get count is count of my data set. Great. It's literally as easy as that. You output something, it outputs something. It's forgiving, which means if you do a join, and this was very interesting when we found this out. We had a join on our system, and left-hand side data set was smaller than the right-hand side data set. And we did a left join, and we ran the query. And what we saw underneath on the details was ECL actually swapped those records. It still kept the join conditions the same. So it just moved those records around, because the way it works is it likes to have the bigger chunk on the left and smaller chunk on the right. Well, we did not know at runtime how our data sets would be. So there was no way for me to know that the left was going to be smaller and right was going to be larger. But it automatically switched it, and a query that would have taken probably hours to run because of the skewness actually ran very fast. So it's very forgiving. You may make a mistake, and it will try to correct itself. The compiler is really good. And it's readable. So if you look at the lines of code, we probably have in our entire code base about maybe 20,000 lines of code. And if you guys write code, and if you're doing some complex financial services analysis, you'll realize that 20,000 lines of code is nothing. And that's because when I have to deduplicate a data set, and how many of you guys actually try to deduplicate a data set using SQL and other technologies, right? In HPCC, it's one line. I write DE, DUP, and the data set. And it actually, without any conditions, it will do a row by row comparison, and it will dedupe it. So that is the strength of this particular technology. Now let's just look at who are we. So data seers, as the name suggests, right? We are taming the data demon. And what I mean by that is we actually have a product. So what do? We are a software as a service company that ingests any data that originates into a financial services company. You could be a bank, you could be a payment system, you could be a network. So for us, typical data sets would look like hundreds of millions of transactions that take place daily on the Visa network, MasterCard network, Pulse network, so on and so forth. So I get one of the feed from there. Processors send us the data. We have data coming from our core banks, which is people like Fiserv, FIS. They send us the data. And our job is to make sense of it. Right? We have to provide that value back in a meaningful time. And here's the funny thing. We get this data mostly middle of the night. Some people, because of Pacific time and Eastern time, I still think that they're actually clicking a button inside their company when they get to work, because we don't get it until 11 o'clock in the morning in Eastern time, right? Our job is, as soon as that data hits our platform, it has to run through all these algorithms and all these reporting to be able to predict or detect money laundering and identity problems and so on and so forth. How do we do it? We actually use HPCC as our core. We, of course, use other technologies around it from a presentation perspective, because HPCC is a data engine. All it does is data, and it handles it really well. But we also use other technologies around, like Elasticsearch and Kibana, to deliver that information. We also have our own set of tools that runs on top of it, which uses simple stuff like Node.js and Polymer, right? So our focus, and why we do it? Well, we are doing it is, we are fighting fraud just like the Feedzais of the world, just like the threat matrices of the world, and so on and so forth. There's many companies out there. So why be another company trying to do the same thing that these hundreds of the other companies are doing? The answer lies in a simple thing that we all lived through. When Google came along, Yahoo existed, right? But they still did Google search, and they still beat them. When Bing came along, they still had Google, but they still did something. When Baidu came along, all of these guys existed, but they had a different mentality. They had a mentality of, I can do it differently, and I can do it better. We feel that we can do or solve this problem better and differently. And I'll give you a simple metric. We have a company we work with, they have 250 data scientists on staff. We have 2. And we are finding more issues than they are. And the only reason is that my guys are not smarter than their guys. There is no way, right? They're paying way more than I'm paying my guys. It's just that we have a piece of technology and the understanding of our data much better than some of the people out there. Let's look at the specific industry we focus on. Like I said, prepaid, right? And this is a comment. Fraudsters are increasingly turning to prepaid cards for the movement of money to perpetrate fraud. And this is very, very, very true. If you look at Zelle, the whole goal, and again, who is paying these fines, right? Banks are paying fines because they can't keep up with fraud and money laundering. Most recent case was US Bank fined $613 million for one case, Scott Tucker. How many of you guys know about Scott Tucker case? Only one, right? He was a race car driver, laundered money, payday loans through a Indian establishment, native Indian, not Indian. We don't know fraud. We don't rob banks. But native Indian establishment laundered money. Nobody could track it. It's a $100 billion bank, guys. $100 billion bank. They have all the money in the world to figure this out, but they couldn't, and they ended up paying a fine. That's because when you try to use a vehicle for unintended use, you cannot predict what's going to happen, right? So prepaid cards were not meant for fraud. They were meant to make payments easy and convenient for all of us. But it just so happens that it's being used as a vehicle by all these fraudsters because they know the mess that exists in the industry. They know that you're not going to catch me, or if you do, by the time I'll be gone. And this is a reality that we are living in. So let's look at a simple architecture of how we do this. So the product we have is called as Financier, and our tagline is a machine learning approach for banking and payments, right? So we ingest structured and unstructured data that is coming into this platform, and our modules are called seers. So we have 2 modules, a file seer and a message seer. It doesn't matter to us how you give us the data, as long as you give it to us. The data comes in, gets homogenized, gets tagged, cleaned, all of that, and then sits in what we call as a data lake. Yes, we do call it a data lake because there is a theory behind it, and I'll tell you in a second. Once the data sits in a data lake, there is 4 modules that we run. The very first one is called as Compliancier. Think RegTech. Do you guys know what RegTech is? Okay, RegTech is regulation coming out from the government, right? So it's funny. I'm not going to go into too much politics here, but I just want to tell you some funny facts that if it's a Democratic government, regulation goes up. If it's a Republican government, regulation comes down. There was an article that came out 2 days ago that the current administration is reducing the regulation in the industry. And it all goes back down to a simple fact. So should there be regulation or should there not be regulation? If the regulation goes up, you and me pay for it because that's where your fees come in, right? When the regulation goes down, fraud goes up. So it's kind of a catch-22. So we have to figure it out. So Compliancier's job is to use a lot of machine learning to figure out if an individual on our platform is exhibiting behavior which is not typical to him. It could be based on, okay, you're exhibiting a 20 to 30 male, but your behavior is that of a 60 to 70-year-old female, or vice versa, right? One of the classic examples that we find on our platform is called as elderly abuse. When was the last time you guys as grandma went out to a bar at 3 o'clock in the morning and paid for drinks? Doesn't happen very frequently, right? It's actually called elderly abuse. A lot of times what's happening is the grandson's girlfriend is taking her debit card out and spending money because grandma is too old to realize and know this. And the money just disappears. It's a very real problem. If you go Google elderly abuse, you'll see anyone over the age of 60 years old is required to be monitored in a bank for elderly abuse. It's the bank's fiduciary responsibility to make sure that this is not happening to somebody. So that's just a simple example. Or another example would be, we would see patterns on the compliance side like There is a bar transaction followed by money loaded, followed by a hotel purchase, followed by an ATM. Can you guys think about what would that entail? It's sex trafficking, right? So somebody is picking up somebody at a bar, they're paying for services, going to a hotel, taking money out from an ATM. Simple things like these, right? If you know the industry, if you have the technology and the tools to look at that, can give you a lot of oversight. Another example would be when we see atypical transactions for travel and hotel only. You know, if you have a prepaid card, if you have a Square Cash or Venmo account, you're going to buy coffee on it. You're going to do something. You're going to go to a restaurant and spend money. When I only see specific type of transactions, that alerts it, right? Now again, let me tell you this. Our job is not to catch these guys. Our job is to show that there is something wrong. We are not law enforcement. We are just making them see this information, right? So we file this information and then they decide whether to do anything with or not. Everybody is innocent until proven guilty, right? At least that's where we live today. The next piece is reconciliation, right? So recon's here. What would you guys think if I told you that there is a lot of payment-focused banks that cannot establish their financial position by the end of the day? I'll explain to you what that means. It means they don't know how much money they need in the bank to satisfy all of their outstanding liabilities. And these are banks. They should know how much money they need in the bank, right? It's like, I have $10 in my bank, so if I go to an ATM, withdraw the $10, I should have that available. On the payment side of things, banks that are payment focused, not just core, don't know that liability today. And it takes them a while to get to it. Sometimes it's 2 days later, sometimes it's 10 days later. What they most likely do is they just leave enough money in the bank and they say, well, you know what, this will cover everything, so we are fine. I'll give you a simple metric. The metric is, if I can predict how much money needs to be in each of these accounts on a daily basis, you get half a basis point from the feds for every day you put money with them. So they're actually paying you interest if you just put that money and park it there for a day and move it back, right? So we use predictive analytics to figure out what your settlement position would be the next day. And this is, we're using a lot of time series data and so on and so forth, but our goal is, if you take that money, extra money, put it with the feds, you're actually not even paying us. We are paying you for using our platform, right? Because you're making money on the interest. So that's the job of Reconcilier, is to do reconciliation across the board, across every single network, trying to figure out what is happening. Fraud's here. So like I said, there is two types of fraud. There is inline fraud and there is out-of-line fraud. We don't do anything inline fraud. Here is a funny thing about doing inline fraud. If you guys are thinking about starting a company to stop fraud from happening, don't. Here is why. One, you are in line of payments, which means now you are subject to laws on how long can you take to determine that transaction is good or bad. If you take too long, you're going to be fined. Two, you have to have massive amounts of data to come up with the right algorithm to stop it, right? And three, there are clawbacks, which means, yes, you can charge them $1 a transaction for every transaction that passes through, but they're going to come back and they're going to say, you pay me $5 for every wrong decision you make, because I'm stopping that payment from going through, right? So we don't touch that. We say, well, you guys are great. We take a different approach. We say, are you guys happy with your inline fraud engine? Most people say yes, absolutely, which means I should never, right? I should never find fraud on your platform. Because if your inline fraud engine is working, there shouldn't be anything. So you don't mind if I check, right? And most of the people say, oh yeah, go ahead. And we run our algorithms after the fact, in the night, to see if there is any undetected fraud. And we find thousands of accounts on the platform which are undetected fraud. I'll give you a simple example. A $900 transaction, actually $961 transaction to be specific, was approved at a gas station somewhere up north. And several went through. It's normal from a processing perspective. Our engine caught it. Why did it catch? Let's look at all the rules that tripped. 961, when you go to a gas station, what are the odds that you're going to have a whole number? Right? I mean, almost never. Number two, when was the last time you spent that kind of money at a gas station? Right? You don't. Even if you go inside the convenience store, you're not, unless you're buying 50 packs of beer. It's impossible. 3, that gas station happened to be in an area that is marked as high intensity financial crime zip code by the FinCEN, which, by the way, we actually have that database on our platform. 4, there were several such transactions going through the system. 5, we realized that money orders were blocked on that transaction. But this was not a money order, it came as a POS transaction. And there were several other rules that tripped, and it started throwing alarms out. And somebody saw it, they found the issue, reported it, and whatever happened with it, we don't know. Most importantly, what happened was a money order was being issued with an $11 fee for $950. So it was $950 plus 11, $961, coming on the transaction as a POS purchase, because the guy that was running it probably was in on it. He said, give me $50, I'll run it through as a regular transaction. Nobody finds out. At the end of the day, everything adds up and we move on. That is what we really do. That's what we try to catch. And the last piece is, I have all the data in the world, I can reconcile, do compliance, do fraud, blah, blah, blah. Why don't we just do general analytics? I can tell you what's happening in your platform, as it's happening, when it's happening, and so on and so forth. We use a different data delivery engine, so we actually don't use Roxy, like I said earlier. We use Elastic and Kibana, because Roxy is more of a data pull and push, whereas Kibana and Elastic, if you guys have used it, and if you guys don't use it, you should look into this, is a technology that allows you to visualize data at whatever speed you want. So we have our real-time dashboards, our batch dashboards. We actually even feed machine data to it. So all the servers going up and down, and CPU usage, memory usage, we feed everything through Elastic and Kibana. And it's also a distributed technology, which means you can run it on multiple clusters, you can run it on multiple servers, and it's truly free. They hate me because we have used it in such a way that we haven't paid them a dime yet. This is about open data science, right? It's all about free technology. So we haven't paid a dime to HPCC. We haven't paid a dime to Elastic and Kibana. And it's fully secure, PCI, PII compliant, in a SOC certified data center, and so on and so forth. So you can throw it, it's two-factor authentication. It's actually multi-factor authentication. So again, powered by HPCC systems. We use I talked about authentication, so let me explain to you what technology we use for that. We actually use a submarine model, which is, you guys probably might know, is if one part of the submarine is flooded or breached, you can still be safe in the rest of them. That's what we do. So we have multiple handshakes through our platform. So by the time you get to the data, there's about 6 or 7 hops, and all of them have to add up before anybody that gets in. So if somebody stole your password, no problem. This system is also running fully in parallel, real time, and DR built into the system, right? So HPCC allows you to do stuff like that. In fact, again, I have a blog post actually I have an article on LinkedIn. Would you delete your production data? How many of you guys here have actually even dreamt of going into your production system and deleting all of your data? Have you? That's the easiest way to get fired, right? I actually did it right in front of my client, and the entire article is on LinkedIn. He asked me, do we have DR? His simple question was, do we have DR? And I said, it doesn't matter what I tell you, you're not going to believe it. You're going to basically say, well, you're just saying it for the sake of saying it. How do I know we have DR? So I said, how about we just delete all of your data? And he's like, no way. I said, yeah. So I deleted the whole data, watched his heart fall to the floor, and almost, if he owned a gun, he would have shot me, right? And I said, hang on, have faith. And in a few minutes, all the data came back. Nobody that was using the data at the time knew that even the underlying system was gone. I completely nuked the system, right? And again, everything came right back, everything was up and running, and people were using all the data, batch was working, everything was fine. And I did not use any external technology. That's the funny thing. Again, on our entire system, the only thing we have paid for so far is the hardware, which unfortunately nobody will give it to me for free. But nothing else we have paid for. So what is our approach, right, for all of this? It's a very simple approach. Clean, ingest, label, augment. What do I mean by that? Any machine learning algorithm to work, for anything to actually make sense, you have to have clean data. You have to ingest that data in a very unique, homogeneous way so that no matter what your algorithm is, it has to work. You have to label your data, right? So a lot of times I go into clients and they will tell me, oh yeah, we have a lot of data, we have clean data, run your algorithms. Well, it's not labeled. I don't know what is fraud and what's not fraud. You're basically telling me to separate milk and water, right? It's going to be hard. I mean, it may be doable, but it's going to be very hard. But we also augment, which is something very different that we do. Again, LexisNexis does the same thing in a way, right? We take data elements from a lot of different unrelated sources. So I tell our customers that, hey, do you have IVR data, which is interactive voice recognition, phone system data? Send it to us. And it's like, well, why? That's nothing to do with financial services. I said, well, send it to us. And what we did with that is we figured out that there was one guy who had 15 different accounts on the platform, but only one phone that he was calling in to check his balance. Boom, we locked him, right? Or website data. We asked them to send website data. Again, why? Well, one IP address hitting 15, 20, 50 different accounts, that's usually a problem. So we augment our data with a lot of information that doesn't exist, which makes our algorithms stronger and stronger and stronger. Our feature set is very rich. If you look at the actual machine learning pieces, we're not doing anything crazy. We're just using the standard algorithms. You know, we are using time series, we're using random forest. And it's funny, I had a conversation with FDIC. How many of you guys know FDIC? Right? FDIC is the body that regulates all the banks to make sure they're not doing anything bad. If somebody tells you you have FDIC insurance, which means the bank goes bankrupt, you know, government is going to cover, blah, blah, blah. FDIC has a very strong stance on machine learning. They want to know everything, how you do it. So if you guys are data scientists here, try to explain random forest to them, right? And I had a conversation with him and I said, okay, we use random forest. Well, how does it work? Well, it's randomly created, you know, entities and we solve and we figure out the solution. Well, no, but they can't be random. It has to be very specific. I said, that's the fun about, you know, trees. That's the fun about decision trees. It's going to try and find a problem. It's just like in a statistical equation. You have to find the lowest point. You're going to start your model from different sides and then see what it finds. And eventually it finds a solution. So we use something very different. So we actually have a lot of predictable models that run before we hand it off and we would do something where we would construct all those trees. We clearly define it in a way where the FDIC and OCC would understand what is happening. And by the way, today, FDIC and OCC does not recognize machine learning as a metric, right, to solve these problems. They don't think machine learning works. So let's look at some of the results that we are seeing. So our 5 seers today look at about 180 plus programs on one of our smallest instance. 180 million cardholder accounts, about 1.2 billion transactions. Again, this is not big data to me, this is small data. We do this in seconds or minutes sometimes versus hours and days, which is what most of our competition does, right? And that's thanks to HPCC, because like I said, big data is not about big anymore. It's about the volume, the velocity, and the variety. So what have we done, right? So data seers plus HPCC systems equals faster reconciliation, lesser fraud, better compliance oversight, and crisp analytics. Resources. So there is 2 resources you guys can go to. Our website has a blog. Our lead developer actually puts out articles on how to use HPCC systems and so on and so forth. And the HPCC systems website itself has resources for you to learn it. Again, it's free. Nobody wants a dime of your money. Trust me when I say that. They will teach you. There are classes that they take, and I know that they had a booth here. I didn't get to see them. I came today and they were gone. But they probably had like these little giveaways which gives you code, a specific code to all of their courses online. And if you didn't pick it up and if you want to learn, just find me, shoot me an email. My email address is really easy. It's ajoshi@dataseers.ai, and I'll give you the codes because it's free. Questions?
Not a question, but a comment. The US Bank case, those transactions were flagged for people.
I'm sorry?
The transactions were all flagged, so it's not.
Correct. They were flagged, but they were not acted on, right? In a way, so so people called in when they found that there were issues and they were not getting it. They called in because of T's and C violation. So what I mean by that is, there is how many of you guys know about Reg Z and Reg E? Right? So there is a rule, there is a law that is supposed to disclose every little bit of a detail of a loan or a credit card terms and conditions that you're giving out. So in this case, what he's talking about is when you say flagged, you have to be careful when we say flagged, right? There was a lot more than a data issue. A lot of it was a data issue, but there was also a lot more than ignorance. People were just ignoring the fact that it was happening. Same thing goes with Wells Fargo when the accounts were being opened, and that happens. Internal fraud is a bigger problem in some cases than external fraud, which means inside the banks and inside the companies, something's happening and you're just not worried about it because you're either getting benefited by it or something. And that's why we collect internal data as well. You could send us emails on people, and we can actually do unstructured analytics on it to see if there were words in there. In fact, we are working on a very interesting case where somebody is trying to figure out the probability of a lawsuit based on phone call information. Completely unrelated to what we do, but it's a fun project to have. Any other questions?
I have two questions. The first one is, how big is your elastic cluster size?
Elastic cluster size?
Yeah.
Okay.
And second one is, regarding the DR examples that you mentioned, in HPCC, is it as easy as tuning a config and it will take care of DR on its own, or do you have to do a lot of work behind the CI?
Great question. So our Elasticsearch size right now is the same size as of our current server. So the way we do it, and it's a little bit of data movement we have to do. So what we do is HPCC processes all of the information. Once it's processed, once it's clean, once it has structured it, we move it to Elasticsearch. Right? So it's actually physically moving the data. We only send data that is required. We don't send everything to Elasticsearch. So our Elasticsearch size, the actual physical size, it's not that huge. It's about 2.5 terabytes of data. So we have 3 nodes of Elasticsearch running on one of our, each client is different. So in this case, there is 3 nodes, which gives me enough resiliency. The next question was around DR. A couple of things you can do with DR, very simple, right? You can actually do a rsync. If you do an rsync outside of HPCC systems, all the data is sitting in file systems, so it can copy and you'll be fine. What we do is we actually use HPCC systems itself for that. So we replicate the data within the system. Why? Simple reason. So HPCC systems has a technology called DALI, which is responsible for the metadata of the file. All it has, it basically keeps information of how to read that file. Without that, you cannot read the file, right? So there's 2 things here, well, 3 things. One is you want to back this up because that's the only way you're going to be able to read this file. 2, you have to encrypt this because if somebody else gets access to this, they know how to read the file. Because if they swipe the file and they look at it, they won't know how to read it, right? And 3, it's key in replication. So what we do is we actually back it up within HPCC itself. It runs every couple of minutes. And you can choose that based on how frequently you get data. So if I get data once an hour, I can only DR once an hour. I don't need more than that, right? So as soon as data is processed, it will push it to a second repository. And it's all handled through config files. But those 2 instances are completely independent of each other. You can nuke this one, and that one will still be on. And that's the beauty of it. But you can if you can put it on a piece of paper, how you want your cluster to be designed, you can do it in HPCC. That's the beauty of it. It's very flexible. Any other questions? All right. Thank you.